Hello everyone, and welcome back to our online lessons. In today's video we will be talking about geometry, and specifically the areas of three shapes. Now immediately you might notice that, hey, why are we talking about the area of a triangle again? We've already talked about that in the past, but in the past we've been talking about how to find the area of a right triangle. Today we're going to find out how we find the area of any triangle. And then we're going to talk about how to find the areas of parallelograms and trapezoids. We'll go into those two with detail later. We'll start off with the triangle, okay? I'm going to make a scalene triangle, meaning that it will have no equal sides and it will have no right angles, like so. So how do we measure this? In order to find this, we're going to need to know two things. We're going to need to know one of its three sides, and then the distance from that side to the point that is looking at it. So let's be more specific. Let's imagine that this side right here, the bottom side, let's imagine that this side is the ground, right? And I'm going to tell you that this side has a length of, let's say, 10. Doesn't matter 10 what. Could be 10 centimeters or 10 millimeters, anything really. Okay, so if this side is 10, I need to know the distance from this side to the point that is looking at it. Again, imagine that this side is the ground. Now, which of the 3 points of the triangle, so 1, 2, and 3, is, let's say, looking at this side? This point is on the side, and so is this point, but this point up here is opposite of this side. You could say that it is looking at this side. It is opposite of it. Okay? You could also think about it in the way of saying the point, the distance from the line to the point that is not on that line. You could think about it like that as well. Okay, so now we know that we're talking about this point, and we want to find the distance from this point to this line. That distance is called the height of the triangle. Basically saying how tall is the triangle. If this is the ground and we place the triangle like this and we want to measure how tall it is, we would take out the measuring tape and we would measure the distance from this point to the ground. You might think, okay, but are we talking about this distance? Are we talking about this distance? Are we talking about this distance? Which one of these is it? Which line do I want? And the answer to that is, well, when you take the measuring tape, let's say we have a person here, right? Let's say we have a person here standing up against the wall and they want to measure their height. So we take the measuring tape and we measure the distance from the top of their head to the ground. Well, yeah, but we don't take the tape and take it over here or over here. We take the tape and we take it directly to the ground, right? Well, that's the same thing with the triangle. We don't want any of these lines that go to the side. We want the line that is perfectly perpendicular to the side that we're talking about. We don't want this line or any other line. We want only the one that is perfectly perpendicular to this side. So there we go. This side is called the height of the triangle. From this point, I symbolize it with an H. This side that we talked about in the beginning is called the base of the triangle, and I symbolize it with a B. Here we called it 10. It could be anything really. It depends on what the problem says. So before we said it is 10. So in this case, we would say that B equals 10. And let's say that the problem tells us that the height is equal to, oh, let's say 3. And then in order to find the area of this triangle, I will be doing the following. The area, come on, the area of the triangle, let's just symbolize that with an A, it's going to be equal to the product of the base with the height divided by 2. It's the same thing, you might notice, it's the same thing as with the right triangle. What's the difference though? In the right triangle, so here we have a right triangle. The base and the height are two of the sides of the right triangle, because that's one of its properties. But in a normal scalene triangle, where there is no right angle, the height is not one of the sides of the triangle. See this line here? I didn't make it originally as a part of the triangle. Remember, I added it on later. Originally, it was not part of the triangle. I added it afterwards. It is the distance between this point and this line. Remember that? We said this is the height of the triangle. Well, here the height of the triangle, to get from this point up here to the base here, we just have to follow the side of the right triangle. So the height and the base are both sides of the triangle in the right triangle. But in a scalene, they are not. However, the formula remains the same. We still need to do base times height and divided by 2. So in this case, it would be equal to what? Well, the base we said is 10, and the height we said is 3. So it would be 10 times 3 divided by 2. Now 10 times 3 is equal to 30, and we have to divide this by 2. So that means 30 divided by 2 is equal to 15. So the area of the triangle in each of these cases is equal to 15. The area of this triangle is equal to 15. There we go. So that's how I find the area of a triangle. Next up, we'll be talking about the parallelogram, and I would suggest that you write this down. You pause the video and you write this down somewhere, because you are going to need it for your exercises on Thursday, on Wednesday and Thursday, and for tomorrow's video when we will be solving examples. Next up, we're going for the parallelogram. The parallelogram is defined as a shape with 4 sides, with 2 pairs being equal and parallel. But the difference with the rectangles, because that's basically the same definition as the rectangle, but the difference is that the rectangle also has to have 4 equal angles. That is not the same with parallelograms. So a parallelogram looks like this. I have to make this line be parallel and equal to the other one that's a little skewed. You see we missed a little bit right here. So let's try and fix that. There we go. This is a parallelogram. And as you can see, we have 4 sides, and this side is equal to this side and parallel, whereas this side is equal and parallel to this side. If we had a rectangle, apart from having 4 sides being equal and parallel, we would also have to have 4 right angles. So as you can see here in the rectangle, we have 4 right angles, whereas here the angles are not right. We could point out that for the parallelogram, this angle is equal to this angle, and that this angle is equal to this angle. But right now, that's not really important. We're not focusing on angles right now. We are talking about area. And with the area, what we care about is the sides. And again, as before with the triangle, we care about the height of the parallelogram, which means the distance from one of the top corners to the base. This distance that I just created is the height of the parallelogram. And this side down here is its base. Finding the area of the parallelogram is a little easier compared to the triangle because all I have to do to find the area of the parallelogram is just multiply the base with the height. Again, copy this. You will be needing it tomorrow and generally the rest of the week and for the weekend. So let's say that the height here of the parallelogram is, let's say, 6. And the base is equal to 13. Then to find the area, I would have to multiply those two. The base being 13 and the height being 6, I would have to do 13 times 6, which gives us a total area of 78. So that's the area of this parallelogram. Copy it again, you will need it tomorrow. Pause the video if you have to. Lastly, we will be talking about the trapezoid. The trapezoid is a four-side shape that has no sides being equal and 2 of them being parallel. It looks kind of like a table. So let's say something like this. Here, what is going on is we have 2 bases for this shape. We're going to call them B1, as in base 1, and B2. But again, like before, we're also going to need the height of the trapezoid, which we find by going to one of the top corners and measuring the distance from that point to the opposite base. This, again, is the height of the trapezoid. Now, how do we find the area of this shape? To find the area, and this is a little more complicated than the other ones, what we do is we take the sum of the 2 bases. We multiply that by the height, And then whatever we find, we divide it by 2. Let's actually write this a little better, the way it should be written. I'm going to delete this from here. It looks a little better if we write it in fraction form. So b1 plus b2 over 2, and then the result of that calculation multiplied by the height. And this is how it should be written. This is the formula for calculating the area of any trapezoid. The sum of the bases divided by 2 and then multiplied by the height. So let's say that in this example, the one base is, let's say, 20, and the other base is equal to 15. Actually, let's say 16. Let's make this a little easier. And the height, let's say, is equal to, say, 10. Well, then let's plug in the numbers that we just put in. Let's plug in the numbers. We said that one base is 20, and the other base is 16. And we also said the height is 10. Well, if we remember our order of operations correctly, what we should do here is first we do 20 plus 16. 20 plus 16 makes 36. And then 36 divided by 2. 36 divided by 2 makes 18. And then we want to multiply that by 10. So my result here is that the area of the trapezoid is 180. That's how I find the area of each of these shapes. Tomorrow we will be solving examples together. I hope you wrote down all the formulas for each of these, because you will be needing them throughout the week and for your weekend homework. So I'll see you guys again tomorrow. Have a good day.